Welcome everyone, my name is András Tálas. I'm Senior Technical Consultant in Comprion. I will hold you the RSP Advanced Training third part, which will be about the profiles and the profile interoperability. Let's start the first session. The agenda. We will have a short introduction about the profile. Then the biggest part of the session 1 will be about the profile format. And at the end of this session, we will have a short summary. Introduction. So, what is a profile? And why do we need a standardized profile format? First let's look at the profile. What is a profile? The profile is a data file which comprises of operator data, for example, IMSI or secret keys, operator applications like the USIM application, and potentially third-party applications which are used for payment or transport NFC applications. The usual profile size is about 5 to 20 kilobytes. So, why do we need a standardized profile format? First, look at the UICC ecosystem. The UICC card can be personalized only one time. This is what we know. It means that only one profile needs to be installed on the UICC during its lifetime. The profile which is installed on the UICC is created by the same vendor who creates the UICC. So it means that there is no need for a standardized format because any company can understand its own profile format. Okay, so what is the difference with the EUICC ecosystem? The EUICC card can be personalized and is normally personalized many times. And each times, different profiles are installed to the UICC, and these different profiles may come from different vendors. And the UICC needs to understand all these profiles. So, proprietary formats cannot be used any longer. There is a need for a standardized profile format. In 2015, Trusted Connectivity Alliance, which was called formerly SIM Alliance, standardized the interoperable profile format. Let's take a look at this interoperable profile format. First, just at the profile coding and the profile structure. The profile coding. There are two coding formats we need to know. One is the ESN1 and the other one is the DER. The ESN1 is a human readable format and the DER is the machine readable format which the EUICC digests. So, how these formats look like? The ESN1 format, you can see it on the left side. It contains human readable parts like header value, like major version. So this is something which human can read and edit. And this part, the ESN1, is then encoded into a DER code, which is then the EUICC who understands. Let's take a look at the workflow of the EUICC personalization. After the MNO orders the profile, in the SMDP, where the profile creation takes part, the ESN1 is coded into DER, and then during the profile download and installation process, this DER in an encrypted channel and in an encrypted format is sent to the EUICC. Alright, so this was about the profile coding, and now let's take a look at the profile structure. The profile consists of one profile header and many profile elements. This profile, which you can see on the screen now, it's just a usual profile with USIM application. The profile header. The profile header, as we saw, is the first element of the profile. The profile header is mandatory. It always has to be in the profile, and the profile always starts with the profile header. The profile header contains some basic information about the profile, the SIM alliance version of the profile, for example 2.3, the ICC ID, the list of the mandatory services which has to be supported by the EUICC, for example runtime environment, file types, the list of mandatory templates to be supported by the EUICC, and take a look at an example of the profile header to see these values. We can see here the profile version, major version and minor version, ICC ID, the mandatory services, and the mandatory template list. We will talk about the template later on, very much in details. The profile elements. The content of the profile is structured into profile elements. Every major standalone part of a profile is encapsulated in a profile element, like PE pin codes, PE USIM, PE security domain, and so on. The profile elements are handled by the EUICC as standalone objects, but there are some dependencies between them. For example, a PE application shall always come after the PE security domain to which it belongs. Let's take a look at the PE header. Be careful, the PE header is not the same as the profile header. Each profile element contains a header section called PE header. The PE header contains two fields. One is the identification, which is a unique identification number of the profile element within the profile. And the other field is the mandated. It indicates if the support of this PE is mandatory or not. Let's see an example of the PE header. So in the USIM profile element, we can see here the USIM header, which is the PE header of the USIM profile element, with the mandated field, which is here indicated with null, which means that yes, this is mandated, and the identification field, which is here for. At the end of this section, let's take a small quiz. I will put questions on the screen and the possible answers, and please choose the correct answers. Sometimes there is only one, sometimes there is more than one correct answers. I will give you some time for thinking and then show you the correct answers. Now, the first question is, what does a profile contain? A. Operator data and application. B. IMEI, which is the International Mobile Equipment Identity. C. Third-party applications, for example, payment. So please choose the correct answers. Let me show you then the correct answers. The profile contains operator data and application and third-party applications. The profile does not contain mobile equipment identity number. Second question. What is true for the UICC ecosystem? A. UICC can be personalized several times. B. The UICC profile is created by the UICC vendor. C. UICC is personalized remotely. Please choose the correct answers. And there is only one of these answers are correct, which is the UICC profile is created by the UICC vendor. Because the UICC can be personalized normally once in the lifetime, and the UICC is personalized locally. Next question. What is true for the EUICC ecosystem? The EUICC needs to handle different profiles. EUICC and EUICC profiles may come from different vendors. EUICC is personalized remotely. Please take your time and choose the correct answers. And the correct answers, all of these are true because the EUICC needs to handle different profiles by nature. EUICC and EUICC profiles may come from different vendors. That's why there is a need for the interoperability profile standard, and the EUICC is personalized remotely. The third question, in which format the SMDP Plus sends the profile to the EUICC? ESN1, BER, DER, or ZIP? Here only one answer is correct. And this is the DER. So in ESN1, the profile is created. This is the human readable format. And then it is encoded into DER, which is the machine readable format, and sent to the SMDP Plus in this form, sent by the SMDP Plus to the EUICC in DER format. Next question. The profile shall start with A. Profile header, B. PEMF, or C. PE header. Which one is true? Correct answer is profile header. The profile shall start with profile header. The PE, the profile element, which is the one which shall start with the PE header. The PE header contains the identification of the PE. Is this true or false? And the correct answer is true. After looking at the profile coding and the high-level structure of the profile, let's take a look at now the profile content and the creation of the file system, which is the biggest part of the profile. The profile content. The profile has two main parts. The first main part is the file system, and the second main part is the security domains and the applications. Let's first take a look at the file system. So what is the file system? The file system contains those files which the network providers puts onto the UICC to provide network connectivity and other services. The file system is basically a file tree, starting with the main file, the MF. And under the MF, there are directory files, which groups files which belongs together. For example, DF Telecom. Application directory files, which additionally has an application functionality like the USIM ADF, and the elementary files. Elementary files are the files which contains the content itself. Let's take a look at two typical file types. One is the transparent. It is a continuous sequence of data units. The other typical file type is the linear fixed, which is a sequence of fixed-sized records, and the records contains the data units. So if I want a graphical representation of these two files, it looks like this on the right sides. For the linear fixed files, these are the records. Let's take a look at the file structure. There are two main parts of a file: the file header and the file content. File content, as I mentioned, exists only for the elementary files. File header. The file header contains the following parameters of the file. The file descriptor. The file descriptor contains the structure type and the record size. File ID, which is a unique identifier of the file. LSCI, which is the lifecycle state of the file. Security attributes reference, which is the reference to the access conditions of the file. DF name, which is a unique identifier of an ADF, and this is only used for ADF. Pin status template DO, it indicates which pins are used in the DF or ADF, and this is only used for DF or ADF. EF file size, which is the size of the file, and it is used only for EF. Short EF ID, which is the short identifier of the file, again only used for EF. And finally, proprietary EF info, which contains specific attributes only used for EF. The file content. This is basically the content is the data part of the file. Only elementary files have data or file content. Let's take a look at the creation of the file system. There are two mechanisms which can be used to create the file system on the UICC. Mechanism 1 is using template, and mechanism 2 is using generic file management. First, we will take a look at the file system creation by templates. So, what are the templates? The templates are file configuration pre-stored on the UICC. Within a template, default values are stored for the file size, number of the records, record size, access conditions, content, and so on. All these default values are defined in the template definition of the SimAlliance technical specification. Take a look at the concrete example, looking at the PEMF template, how a template looks like. So, in this table, we can see here listed the properties of the files. Let's take a look at the second column, which is the EF name. Here we can see all the files which are part of this template. PMF template contains the MF, EFPL, EFICC ID, EFDIR, EFARR, and EFUMPC. The first column contains the file ID, which is a fixed value. This third column contains the file type. For the MF, it's an MF. For the EFPL, this is a transparent type. Same for the EFICC ID. For the EFDIR and EFAR, these are linear fixed file. And finally, for the EFUMPC, this is a transparent file. In the next column, we see the number of records. For some file, this is not applicable. The transparent files contains no records. For the linear fixed file, this is applicable, but we can see that in this template definition, here is no concrete value, button X. It means that this property is not defined in the template. It will need to be defined in the profile. For the EFUMPC being a transparent file, the number of records is not applicable. Then the file size, record size, we see that for some files it's defined, for some files it's undefined. Then the access rule, which is the access rule, a identifier protecting this file. And finally, the short file ID. Short file identifier is not defined for all files. It defined for some specific files. This was the file header part. This is the file content part. The default value. For some files, the template contains a default value. Here, for example, for EFPL, there is a default value defined here. So let's take a look at these two columns with orange. The blue part was the part which is defined in the template, and all what we can see in the blue part, this is on the EUICC pre-configured. The orange part is the part which we need to put into the profile which we send to the EUICC. In the orange part, we can see an indication if there is a content required for a specific file. For the MF, there is no content. As we said, content only exists for an EF. For the EFPL, there is no content required to be defined because there is a default content already. Content is required, however, for the EFICC ID, EFDIR, and EFAR because no default content is defined. And regarding the parameters, those parameters which has not been defined in the template definition needs to be put into the profile, and this is indicated in this column. For the MF, we need to define a pin status template DO, which contains those pin codes or the references to those pin codes which are used in the MF. And for the EFDIR and EFAR, we need to define in the profile the record size and the file size. Those two parameters which we saw in the template definition with an X, which were undefined. Let's see 3 examples how we use in a profile the templates. So, within the profile, when we want to create an MF, we see that the template itself requires to define the pin status template DO parameter. So within the profile in the PMF, when we want to create an MF, this is what we indicate. For the MF, within the file descriptor structure, we put the pin status template DO tag with a specific value. For those files where we need to define content, in the profile we put the file and we put the content using file content, or there are 2 other possible parameters which can be used to create content. We will look at those, but here we use file content, and here we define the value. And there is a third possibility when we want to overwrite a value which is defined in a template. Here, for example, for the EFPL, we want to overwrite the access rule. The access rule value here is 1, and we want to overwrite to reference to another access rule. The access rule property in the profile, it's security attributes referenced. So we use security attributes referenced with a specific value. So this is an example how we can overwrite the profile content. Let's take a look at now the template types, because actually there are 2 types of templates. One is the created by default template, and the other one is the not created by default template. What these names mean. The created by default template. So when we use a created by default template, all the files which are defined in the template and pre-installed on the UICC are created without listing them in the profile. We will see that the big difference for the not created by default templates, that for the not created by default templates, only those files will be created on the UICC which are listed in the profile. But here, for the created by default templates, all the files are created without listing them in the profile, and we need to list the files in the profile only if file content or some file parameters are not defined in the templates. We saw some examples for this, or if we want to change a default value, or if specifically I want to indicate that one file is not needed. These created by default templates are used for those files which are typically need to be created in a DF or ADF. In the not created by default templates, we are putting those files which are needed for specific services and not always needed. The created by default template examples are PEMF or PEUSIM. Let's take a look at the concrete example of PEUSIM. In the right two columns, content required parameters, we can see that for which file we need to define either a parameter or we need to define the content. This is if we just count 3, 4, 5, 6, 7, 8 for 8 files. By default, all these 30 files, approximately 30 files, will be created, but we need to define something only for these 8 files. And let's take a look at what is in the profile, in the file which we send to the UICC. So in a PEUSIM profile, we need to put for the ADF USIM, we need to put the ADF USIM because it requires some parameters to be specified. We need to put the EF IMSI because there is no default content and we need to define the file content. For the same reason, we need to put the EF EAR. In this example, we are using a link. We put here the EF USD, but here for two reasons. One of the reasons is file content needs to be defined, but I also wanted to show here that if I want to change the default content, here the file size, I need to put the file in the profile. So these two parameters are in the EF USD, put into the profile. Then for the EF SPN, file content needs to be specified. Same for the EF EST. Same for the EF ACC, ECC. And finally, for the EF EPS loci, I indicated here that I do not want to create this file. So if we look at this profile part, the PEUSIM ADF, it contained 9 or 10 files, and on the UICC, all the files which are part of the templates are created. Okay. Let's take a look at now at the not created by default templates. When using a not created by default template, only those files are created on the UICC which are specifically listed in the profile. So we need to mark those files in the profile which we want to be created from the not created by default templates. As I mentioned, the not created by default templates are used for those files which are optional and not always needed in DF or ADF, needed only for some specific services, for example. And then one example is the PE opt USIM optional files for the USIM ADF. Let's take a look how the template looks like. And the example which I chose here was the PE opt USIM template. So this is a not created by default template. We can see that it contains quite many files. So it contains approximately 100, maybe less, but let's say 80 files. And how we use this not created by default template, this is what is in the profile. In the PE opt USIM, we need to mark only those files which we want to be created. So out of those 80 files which are listed in the PE opt USIM template, I want to create only 4 files: EFLE, EFMSISDN, EFExt5, and the EFIPD. For the EFLI, for the EFMSISDN, and for the EFExt5, there was no parameters or content needed to be defined because the template contained all the parameters and the default value. For the EFIPD, I have to specify the record size and the file size value. After looking at the templates, now see the other method for the file system creation, which is using generic file management. With the template, the main thing was that the template means basically that there are files pre-configured on the EUICC. And the profile which we send to the EUICC needs to contain only a very limited information. So in case of generic file management, the profile needs to contain all the file parameters and all the data of each file which we want to create. Generic file management is typically used when there is no template available for certain files. Let's take a concrete look at how we create an EF with generic file management. So we need to create each parameters, starting from the file descriptor, which indicates the file type and the record size, then the file ID, which is the identifier of the file, security attributes referenced, which indicates the access rule assigned to this file, EF file size, indicating the size of the file, and the short EF ID. And also we need to define the file content. And that's what we need to do for each EF. For an ADF, there is no content, so we need to define only these parameters like file descriptor, file ID, the DF name, security attributes referenced, and the pin status template DO. And then let's take a look at a concrete profile element within the profile when we want to create an ADF USIM by generic file management. We need to indicate, you can see here, each and every parameters for each and every file, starting from the ADF USIM, then for the EFMC, and so on and so on. And I just scroll down, you see here listed all files which are needed for the ADF USIM. And this was approximately, it was, let's say, 9 slides. And if I want to create exactly the same content using template, here we can see that this is only 1 slide. So here we need to list only those files where some specific parameter or content was needed, and it means a very big difference in the size of the profile. There is one part left for the file system creation, which is the definition of the file content. Let's take a look at the last part of the file system creation, which is the file content definition. There are three possible ways to create the file content. One is using fill file content. We see this already in some examples. The other is using fill pattern. And the last one is using repeat pattern. You can see that the last two contains in the name a pattern. These methods or these parameters are used when the file content has a pattern in itself which is just repeated. And then in the profile we just need to indicate this pattern, which reduces the size of the profile. Let's take a concrete look first how to use the fill file content. So here we have a file which is record-based file. Each record has a size of 37 bytes, and we want to fill up the records. So the file content is not always 37 bytes. The first file content, first record, is 27 bytes, the data which we want to put. So after putting the data, we need to put a fill file offset with value 10. Then in the second record, where the data itself is 22 bytes, after this we need to put a fill file offset of 15 bytes, and so on and so on. And when we use a repeat pattern, we just need to indicate the repeat pattern, the pattern here. One thing to mention, that the repeat pattern is part of the file header within the proprietary EF-info tag. Let's take a look at now the file system templates which are defined in the SimAlliance technical specification version 2.3. First is PEMF. This is a created by default template, and it is used to create and set the content of the files at MF level. It shall be used only once and at the beginning of the profile package. PECD. It contains configuration data for the smart card web server. It is a not created by default template and used to create the DFCD and to create and set the content of the files at the DFCD level. It may be used only once and after the creation of the MF. PE Telecom. This is not created by default template. It is used to create the DF Telecom and to create and set the content of the files in it. And it may be used only once after the creation of the MF. PE USIM. We already saw this. This is a created by default template used to create the USIM ADF and set the content of the files in it. And it may be used several times after the creation of the MF. PE OpUSIM. This is not created by default template. This is used to create the files less often used under the USIM ADF, which was previously created by the PUSIM. And it is used once for each USIM application after the creation of the USIM mandatory files by the PUSIM. PE phonebook, not created by default template. It is used to create the DF phonebook inside the ADF USIM and to create and set the files in it. It may be used only once after the creation of the USIM ADF. GSM access. It enables to access the GSM networks, these files. This is not created by default template. It is used to create the DF-GSM access and to create and set the content of the files used in it. It may be used only once after the creation of the USIM ADF. PE ISIM, created by default template, used to create the ISIM ADF and to set the content of the mandatory files in it, and it may be used several times after the creation of the MF. The opt ISIM, which is not created by default template, used to create the optional files under the ISIM ADF, which was previously created by the PE ISIM, and it is used only once for each ISIM application after the creation of the ISIM mandatory files. SysIM, created by default template, used to create the SysIM ADF and to create and set the content of the mandatory files used in it. It may be used several times after the creation of the MF. PE opt SysIM, it's not created by default template. It is used to create the optional files under the SysIM ADF, which was previously created by the PE SysIM, and it is used once for each SysIM application after the creation of the SysIM mandatory files. EAP, it is not created by default template, used to create the DF EAP and to create and set the content of the files used in it. And finally, 2PE is the PE5GS. This is a new PE which is defined to contain those files which are related to the 5G access. This is not created by default template, and it is used to create the DF5GS under the USIM ADF and to create and set the content of the files used in it. And finally, PESAIP. This is SimAlliance specific PE profile element. This is not created by default template, and this is used to create the DF SimAlliance interoperable profile under the USIM ADF and to create and set the content of the files used in it. Currently, there is only one file in the version 2.3, only one file which is related to the 5G in this template. Okay, so we have reached at the end of this long session of file system creation by templates by generic file management. So as a kind of break, let's take now again a quiz. Most of the questions here will be true, false questions. So let's start. First statement. By using templates, the profile size will be bigger. Is it true or false? It is false because, as we said, the templates are predefined file content on the UICC. So when we use template, the profile size itself, which is sent to the UICC, is much smaller. Second question. Every file in the template has a default value. Is it true or false? Okay, so the correct answer is again false because there are files in the template, you remember, where we need to define the content. There is no default content, or we need to define parameter values because these are not defined in the template. Next question or statement. When using GFM, generic file management, every file parameters have to be specified in the profile. Is it true or false? And the correct answer is true because when we use generic file management, there is nothing on the UICC side which would be predefined. So we need to put every file parameters which we want to install in the profile. Next one, when using templates, no file parameter has to be specified in the profile. Is it true or false? I think I helped a little bit with the previous answer to answer this statement as well. So the correct answer here is false because there are some files where we need to define parameters in the profile or when using templates in the profile also. Next one, PEUSIM and PEOPTUSIM are both created by default templates. I think this one is an easy. The correct answer is false because the PEUSIM is a created by default template. It contains the mandatory files which are typically used within the USIM ADF, and the PEOPTUSIM, this is not created by default templates, which contains those files which are less often used, which are specific to some services, for example. And the last question in this quiz, what fill file content is used for? A, to indicate the size of the file, or B, to define the content of the file, or C, to identify the file. Take your time and we will see the correct answer. And the correct answer for the fill file content is used to define the content of the file. After we take a look at the file system creation, how we create the files by template or by generic file management, let's take a look at the other profile elements which are part of the file system. These are PE-PIN codes, PE-book codes, PE-AKI parameters, PE-CDMA parameters. Let's start with the PE-PIN codes. The PE-PIN codes contains the pins which are used in the profile, and there are two types of pins, global and local pins. The global pins are valid in the whole file system, while the local pins are valid only in a DF or ADF. According to this, there are two types of PE-PIN codes. One is the PE-PIN codes global. In the PE-PIN codes global, the global pins are defined. The global PE-PIN codes needs to be in the profile after the PEMF. The PE-PIN codes local, it contains the local PE-PIN codes which are valid only locally for DF or ADF, and the local pin code within the profile needs to be after the PE, which creates the DF or ADF where the local pins are used. In this example, the local pins, PE local pins are used for the PEUSIM, and the PE pin codes local is put after the PEUSIM and the PEOPTUSIM. Let's take a look at the parameters which are used in PE pin codes. To define a pin code, first we need to give the key reference. In this example, this is the second pin application 1, which is the first local pin 1. Then we need to define the pin value. For this pin, it's 1111. Then we need to define the unblocking pin reference, which is basically the book code used for this pin. This is of course optional. We need to define the pin attributes. We will see this in the next slide, which possible values it may contain. And we also define the maximum number of attempts and the retry number left. Let's look at the pin attributes. The coding of the pin attributes is as this displayed on this picture. The first bit sets the pin state, if the pin state is enabled or disabled when the profile is installed. The second bit sets if the PIN can be changed or the PIN change is forbidden. And the third bit sets if the PIN state can be changed or the PIN state cannot be changed. State change means that the user, for example, can set on his mobile phone if he wants to enable or disable the PIN. The next PE is the PE pack codes. The PE pack codes contains the packs which are used in the profile. The usage of the PE pack codes is optional. If this PE is not present, then the pack functionality is not available. The PE pack codes needs to include all the pack codes for the complete profile. And let's look at an example of a PE pack codes. To define a pack code, we need to give the key reference. Here is pack application 1, which is a global pack code, the pack value, and the maximum number of attempts and retry number left. I would like to stop here for a minute, and with this maximum number of attempts, retry number left shows that there are some values within the ASN1, within the profile parameters, which has a default value. Some parameters has default value. One of these parameters is the maximum number of attempts, retry number left. It has a default value, which is 117. Decoded, it means that the maximum number of attempts is 10 and the retry number left is also 10. In case we want to install a pack code with this value, with the default value, then this parameter maximum number of attempts, retry number left, is not need to be in the ASN1. And this is the case for the key reference pack application 2. After the PE pin codes and the PE pack codes, there are two PEs left. One is the PAKA parameter, which is used to set the parameters for the AKA authentication algorithms like the Milnage, DUAC, and the USIM test algorithm. The usage of the PAKA parameter is optional. Let's take a look at an example. Without going into details for the specific parameters, let's just take a look that there is an algo configuration part where we define the algorithm ID. In this example, this is Milnage. Then we define here the keys, some constants which are used for this AKA algorithm. We define SQN options, so all of these parameters which are used for network authentication. And the pair of the AKA parameter is the CDMA parameter, which is used to set the parameters for the CSIM authentication algorithm called CAVE. The usage of the PCDMA parameter is optional. And let's look at an example just to see again it contains keys and specific parameters which are used in the CAVE authentication algorithm. Okay, so we have reached at the end of this part, and as we did so far twice, let's again play a quiz, and this will be the last quiz of the first session of this training. All right, so first question: a PIN code can be global or local, and the answer is true or false. Should be easy. The answer is true. Next question, bit harder. PIN attributes is used to define the value of the PIN. Is it true or false? The correct answer is false. because the pin attributes is used to define some specific parameters of the pin, like is it enabled or disabled, pin value can be changed or cannot be changed, but not the value itself. Third question statement. A local pin is valid only in the DF or ADF where it is defined. True or false? This statement is true because local pin is valid only in the DF-ADF where it is defined. And the last one, PEPUC codes is allowed to be used only once in a profile. Is it true or false? Correct answer is true. It is allowed to use only once in a profile. Now that we reached to the end of the first session, let's have a short summary about what we have learned in the first session. So, we have learned what is a profile. We have also learned why there was a need to standardize the UICC profile format. We learned how a UICC file system looks like. We learned how do we use templates to create the file system. Also, we learned how do we use the generic file management to create the file system. Finally, we take a look at the content and the parameters used in the PE-PIN codes and the PE-PUC codes. Thank you for your attention now, and we will continue with the session second